The next set in the notes is to name each quadrilateral, either parallelogram, rectangle, rhombus, or square, for which the statement is true. So the first one says it is equilateral. So I have to think about things that are equilateral. Parallelograms are not always equilateral, neither are rectangles, but rhombuses and squares are. So the answer to this one is rhombus and square. On the next one, it says the diagonals are congruent. That is true for a rectangle. And we just learned that in one of the rules. And if it's true in a rectangle, then it's also true in a square, because a square has the same properties, has all the properties of rectangles and rhombuses. Next one, it can contain obtuse angles. Rectangles and squares can only have 90-degree angles, so this doesn't apply for those. Rhombuses can have obtuse angles, and so can parallelograms. And then the next one, it contains no acute angles. So on number 9, if it's going to have obtuse angles, it will also have acute angles. So number 10 is only going to work for the ones that have only right angles, which means rectangles and squares. So those are those two. All right, the next thing here says that we've been given a rhombus. It says the diagonals of a rhombus, PQRS, intersect at T. Given that measure of RPS is 30, and they labeled that right here with the 30, and RT is 6, they labeled that too. Find the indicated measure. All right, what I know in rhombuses is that the diagonals always make a right angle. I also know that the diagonals bisect each other, so if this is 6 here, then this will also be 6. What that's giving me is it's giving me a 30, 60, 90 triangle in this rhombus. So if this one's 30, this one would be 60, and this one would be 90. And let me see what all they want us to get. Oh, another thing about the rhombuses is that the diagonals bisect opposite angles. So if this is 30 on the left here, then above there's 30. And then if this is 60, because the 30 and the 90, and subtract from 180 to get 60, then this is 60. So we have a bunch of 30, 60, 90 triangles in our picture. And unfortunately, the 6 is across from the 60, so it's one of the more challenging 30, 60, 90 questions. And I see that they're going to want RP. Well, that's just the 6's added together, so I can get that one easily as 12. Let's see, QPR. We've got all our angles, so we can answer these angle questions. Q to P to R is this 30-degree angle up here. And then Q to P, Q to T to P. In the middle, these are all right angles, so that's a right angle. So I answered 3 out of 4 questions without doing much work. The last one here, though, QT, is going to require some work because they want the other diagonal. That's this part right here is what they're looking for from Q to T, which is across from the 30-degree angle. So I'm going to have to set up my 30, 60, 90 triangle table here, x root 3, and 2x. The 60, across from the 60 is a 6, and so if you're in regular geometry, you could just divide by root 3 to get the 30 and give me a decimal, but pre-AP, hopefully you are dividing by root 3, and then remember rationalizing that out means that you end up dividing by 3 and multiplying by root 3. And 6 does divide by 3, and you get 2 root 3 for the 30, which is the one that we want. So QT is 2 root 3, because it's across from the 30. If we wanted the outside side of this rhombus, we would just do the 90. We would have to double that. Hello? Hello? Yes. Yes, ma'am.